Complex fractions are another very common limit, as you can see here with this one. Fractions within fractions, if you plug in 0 into this equation for x, you'll get 1/4 minus 1/4 is going to be 0 on top, 0 on the bottom. There's your indeterminate form, so that's no good. We need to find some way to algebraically manipulate this. And the only way you can do that with fractions is, well, try to make a common denominator. And this is going to be a lot of fun. So basically, we need to make a common denominator with these guys on top. And the most common and easiest way, if this guy has a denominator 4, that means you need to multiply this first fraction by 4 on top and bottom. Same here, the second fraction needs to get the x plus 4 on top and bottom to multiply through. Now here's where you can either be really good or really bad in terms of your ability to solve this, just based on how neat you are in solving and writing out your equation. So 4 times 1 is 4. So it's now 4 over, the denominator is 4 and x plus 4. The second fraction becomes x plus 4 on top, and we still have 4 and x plus 4 on the bottom. And don't forget, that whole thing is still divided by x. We need to try to combine some things together here. This whole top can become one big fraction. So limit as x approaches 0. 4 minus, now this entire thing is what's being subtracted. So 4 minus x plus 4 all over 4 and x plus 4 multiplied, all that still over x. And again, make sure you're consistent with how you're doing your fractions. We can clean this up a little bit. My numerator up top, 4 minus x, and then really I'm subtracting 4 again, so I just have a negative x on top over, now this 4 and x plus 4 is in the denominator. This x is also in the denominator. If you want to think of this as even a flip and multiply, so instead of dividing that whole thing by x, multiply by 1 over x, notice you now have in your denominator that x to go along with the 4 and the x plus 4. And now this should look like a really simple problem compared to how we began, because we have an x on top and bottom that have gone away. That helps us big time, because now we have the ability to be able to plug in. We have just negative 1 on top, 4 times x plus 4 on the bottom, plug in 0 for my limit value, negative 1 over 4 times 4 on the bottom, 16. So negative 1 over 16. Give another example. See if you can go through it. I would say pause the video first, give it a try. It works very similarly to the last problem. So it's amazing how similar these problems can end up being when you do them over and over again in calculus. But you're going to have to multiply by 3 and x minus 3 on top and bottom. And when you do that, you should end up getting the limit as x approaches 0. Remember, keep that here until you actually plug in. So now you have 3 plus x minus 3. Your denominator is 3 times x minus 3, and that whole thing is divided by x. I'm the type of person, I like to get rid of that divided by x, so I do times 1 over x immediately. You can flip and multiply there. You can do your simplifying first. It doesn't really matter at that point in time. Either way, though, your numerator, you have 3 and negative 3 going away, so you have just x. Your denominator is 3x minus 3 and x. And just like the last problem, just like all these, eventually the x's will go away. It's nice when the x's go away. 1 over 3 times x minus 3. Plug in 0 for your x value now, because you don't have an undeterminate form. And you're left with 1 over 9. So there's complex fractions in terms of limits.